Chapter 2. Radio Frequency Fundamentals. In this chapter, you will learn about the following. Electromagnetic spectrum is the entire range of wavelengths of frequencies of electromagnetic radiation extending from gamma ray to the longest radio wave. The science generally classified electromagnetic wave into 7 basic types: gamma ray, X-ray, ultraviolet, visible light ray, infrared wave, microwave and radio wave. High frequency will shorten wavelength and vice versa. Radio frequency characteristics. A wave is a type of disturbance that travels through a medium in a given time. Wireless communications are conducted over radio wave. These are radio frequency characteristics. Please refer to Chapter 1 for more information. Radio frequency behaviors. Wave propagation. The way in which the radio frequency waves move. Analogy. When there is an earthquake, propagation will occur around the earthquake area. Another example is, when throwing a stone into a river. When the stone enters the water, you will see propagation take place like this animated example. Absorption. The conversion of the radio frequency signal energy into heat. This is radio frequency signal. If the signal does not bounce off, move around, or pass through an object, then 100% absorption has occurred. For your information, absorption is the leading cause of attenuation or loss. Example of analogy here is the sound absorption by soundproof wall. Reflection occurs when a propagating electromagnetic wave strikes an object that has very large dimension in comparison to the wavelength of the propagating wave. The best analogy to express reflection is pointing a laser pointer to a mirror. It will reflect back. This is surface A, and this is surface B. We can see that the direction of reflection may vary depending on the surface of the medium. Scattering can most easily be described as multiple reflections of attenuation or loss. The analogy for scattering is pointing a flashlight to a disco mirrored wall. You can see the animation provided here to see how scattering takes place. Refraction is the bending of a radio wave as it passes through a medium of different density. 2 examples of medium here: water vapor and water. Based on the animation, the exact position of the fish was not properly placed on the person's side due to refraction. Diffraction is a wave bending around an obstacle. An example of the diffraction analogy. When flowing water hits a rock in the middle of the river, then the water flow will change due to the rock obstacle. This animation shows the wave changing as it passes through obstacles. This is obstacle A, and this is obstacle B. You can see the difference in wave movement of each obstacles. Gain is an increase in signal amplitude, where loss is a decrease in signal amplitude. Just remember the keywords, increase and decrease. Multipath is a propagation phenomenon that results in 2 or more paths of a signal arriving at a receiving antenna at the same time, or within nanoseconds of each other. The 4 possible results of multipath are upfade, downfade, nailing, and data corruption. Bonus: free space path loss. I leave this for you to find and read in the book. Chapter 2 Summary. Radio frequency characteristics and radio frequency behaviors. End of chapter. Thank you for watching and listening.